Right, so I'm here to talk to you about content security policies and breaking things and avoiding doing what I've done. Just quickly, because you all totally care about this. I'm Matt, I'm a senior software engineer at a company called Viva IT. We're the guys who always wear the orange hoodies at conferences, so if you've ever been to Symphony Live or PHP Northwest, anything like that, we'll generally be a group walking around with bright orange hoodies. On Twitter, I'm Brunty, if you need to talk to me about anything or get in touch or ask questions about anything you've heard tonight. I'm also at PHP-EM, which is PHP East Midlands, user group based in Leicester primarily. Website, email address, you don't care about that. Things I do. Bit of background, I fly quadcopters, first person view, acrobatics and racing. I'm a dungeon master for Dungeons & Dragons campaigns. I mentor, lead and teach junior developers and apprentices, primarily where I work. I run and organise PHP East Midlands. I speak at user groups and conferences. And I break production websites with content security policies. So, why do we need content security policies? I'll give you a bit of background about what they're needed for and how they protect us. So, when your browser loads a web page, it loads a lot of other assets, a lot of other resources with it. It doesn't just load HTML. HTML tells it, hey, pull in this script from my domain, pull in Google Analytics, style sheet, images, potentially iframes, that side of things. They could be external resources, but they could also be within the HTML inline as well. And the browser loads these because it was told to. It was told by the server sending the response, hey, just, that's what you need to load. Your browser doesn't know that if in that source code that's sent back, it's got a script tag for mybadsite.com/superhack.js. It doesn't know that it's meant to load, it doesn't know that it's not meant to load that resource, so it will just do it. It doesn't care that it loads, it just goes, you asked me to, so I'm going to do it. So your server's been compromised there in some way, potentially, and serving bad content. Generally, it's known as an XSS attack. And content security policies help us protect against that type of attack. So what is a cross-site scripting attack? It takes a normally non-malicious site, so a site that you've previously trusted, a site that you are familiar with, a site that you don't think is going to do anything bad to you, and it turns it to the needs of an attacker. And what that attacker can do is, load in external scripts and take that site that you trust and go, I'm going to turn it against you and do bad things. XSS, that's what it does, it enables the attacker to take that site. And in 2016, there was a 61% likelihood that any vulnerability found on a web app or a website was browser related. So that means the vulnerability is not on the server side in the back end, SQL injection, we're talking about browser-based vulnerabilities here. And of those browser vulnerabilities, 86% were XSS based. So what that means, in all of the vulnerabilities that were found in this study, over 52% were XSS based. That's over half of all vulnerabilities found are XSS-based attacks. People often think that XSS is not a big thing. What can they do? Insert an image, put a little bit of CSS in. That's not true. What they can do with XSS is anything that you can do in JavaScript. Anything that you can do with a script in your own site. They can get a script loading from their site. You can do that as well. So that means you can make modifications to the DOM of the site. And when you've made those modifications to the DOM of the site, you can completely replace the page if you want to. Change where all the forms are going. If your bank gets an XSS attack, change their login page. It's no longer pointing to their service, it's pointing to mine. If I'm the attacker, cool, I've now stolen your bank login details, I'll go and help you with your money. Thank you very much. You can use XML HTTP requests to make AJAX requests and HTTP requests to other websites. You can access HTML5 APIs, webcam, microphone, geolocation. Those generally require permission from a user to do so, but as I previously mentioned, you're doing this on a site that the user's already trusted. They've already trusted that site. I don't mind you accessing my microphone, I'll let you do that whenever you want. That site has an XSS vulnerability, the attacker's now got access to your microphone whenever they want because you've trusted that website indefinitely. You can steal cookies, and therefore you can steal session cookies. And because of that, you can now log in as that user on your system. It's not as a nice little vulnerability, it doesn't matter. There's some serious stuff that can happen. Some well-known XSS attacks in the wild Twitter had a self-retweeting tweet. Who encountered that or saw that? Basically, it was a tweet, they got XSS in on it, and the tweet just retweeted itself by anyone who saw it on their page. So it just propagated like that. Spread like wildfire. That was in TweetDeck primarily. There's a video on that, and a link will be in the slides. There was Sammy Worm, known as js.spacehill, I think it was, on MySpace. Within 24 hours, I think, it propagated to 1 million accounts. It's quite a lot, pretty quick. One of the fastest spreading worms in history. Facebook, XSS attacks, there's been tons of those, and most of the big sites have had an XSS attack of some sort. A lot of them will offer bug bounties. If you find an XSS attack, they'll say, cool, thank you for letting us know before going and doing bad things. Here's a little bit of money to say thank you for that. A lot of that sort of stuff exists. And if they don't, then the people get pissed off and do whatever they want anyway. There's many, many more. So I'll go through the types of XSS, and this is all relevant because the types of XSS help us help me explain what CSP does later on. So the first type is called stored XSS. So it's persistent, it's type 1. It happens when data is stored somewhere, usually on the server in a database. So you've got an input field that takes, a Facebook status update, and you go and store that in your database somewhere. Obviously that Facebook update is then displayed on other people's pages. You go and type in a script that's then stored on the database. Everyone who loads that status on their timeline would be affected by that if there was a vulnerability. But it's not always through server storage. HTML5 has APIs for local databases in local storage. So you could potentially store something on the user's system that is never actually sent to a server. That's quite a big thing. The server wouldn't know about it. If it's on your server, you can, in logs, other things, you could find the data there, but if it's never come to your server, you'll never see it. And there was a site called Whois, which does domain lookups, and it was rickrolled by someone. They put a TXT record on their domain that contained an iframe to the YouTube video for Rick Astley. Whois displayed that, and everyone got rickrolled by it. Fantastic. There's reflected XSS, which is the next type, which is non-persistent. Type 2 is called. This occurs when input provided is pretty much returned to the user as it was. So think a search string. You're searching something like Google. If they were vulnerable, you search for a malicious thing, and when it's returned to the page, if it's the string you've searched for is output on the page to remind you of what you searched for, it would be exploited. Data's not stored, so it's never persisted anywhere. It's just reflected back by a URL or something along those lines. And it doesn't even necessarily at all reach the server, and that's where the next type of XSS attack, called DOM-based XSS, comes in. This happens when the flow of the attack is completely within the browser. So if you've got like a single page app and you're using lots of JavaScript components, you're taking input and modifying that and outputting it back to the DOM without touching the server. That's another form of XSS attack. There's a fourth type called self-XSS. It's generally not considered a true form of XSS because it's a social engineering-based XSS attack. It requires the user to execute code for you, effectively. And it does so via the console, which in most browsers can't actually be protected because the console is like a privileged level of code execution. A lot of the things that something like a content security policy protects against can't be protected against via the console. It's considered a privileged thing. And it's not considered true XSS because it requires the user to execute the code. But to make sort of a comparison, it's similar to locking down all access to your server to your developers and whatnot, and only a few key people, and then someone else comes along and says to those people, hey, can you just go and execute this command on the server? And they happily go and do it. It's a bad idea. So you can protect against this kind of thing, or warn users, not necessarily protect, but help warn against them. Who's ever inspected the console on Facebook? You get something like this. So Facebook puts a message out there that says, if someone's told you that you need to put this code into the console in your browser to unlock this super amazing feature, don't do it, because it will likely give them access to your account. You can't stop them doing it, but you can warn them to how to do so, and how to get more informed on it. Something like that's really easy to implement. It's just a console.log with a bit of styling. Go and implement it on any of your sites just to kind of help along those things. So, hackers are attacking us. Let's fight back. Let's stop the hackers in their hoodies and their laptops and their evilness. And let's actually implement a CSP. So, what is a content security policy? At a basic level, It's a HTTP response header, and it helps reduce XSS risks. So the key word here is reduce. It doesn't solve all of your problems. It is not a silver bullet. It doesn't fix everything. It's just one thing in the tool belt that you need to have to protect against attacks. It's another thing to have. And it works by declaring what resources are allowed to load on your web page. So as I mentioned previously, your browser is loaded. You load a web page. The browser's told, hey, load these resources. Previously, the browser didn't know what it should and shouldn't load. It didn't know that it was only allowed to load certain resources from certain locations. But with a CSP, you can define and tell the browser, actually, I only want to allow you to load scripts from this domain, or myself, or these places. And you can basically tell the browser, anything that isn't that, don't load it, just block it. So with this, we can protect a number of different things. We can protect most of the things that you might load in a browser. I'll go through some of they're called directives, and that's how you define what is affected by the policy that you're putting in place. So default source is something that basically acts as a fallback. Anything that isn't specifically defined in your policy falls back to default source. If you declare default source but then declare a script source, like so, later on, anything that isn't a script will fall back to default source, but scripts will be affected by script source because you've specifically defined what rules affect them. Anything else just falls back. I can't remember who said it actually off the top of my head, but there was a quote once that, who here includes Google Analytics from Google on their site from a third party? That is consensual XSS. You've consented to cross-site scripting. You've basically said, I trust them running code on my server, so I'm going to let them do it. Don't realize you're doing XSS when you do that sort of thing, but that's what it is. You can also protect styles, so CSS and that kind of thing. But not only can we declare the resource types that are allowed to load, we can do some really neat and fun things with CSS. So we can do something like this, which is upgrade insecure requests. Who's ever been to a website and it loads over HTTPS, and then they've got an image that loads over HTTP, and Chrome goes, yeah, that page isn't secure. It used to be they would warn you. Now, it probably doesn't even load it. They're updating these kind of things fairly regularly. What that does is it basically says, if you see a request for a resource that's HTTP, request it's HTTPS instead, just like that, and the browser will enact that. You can specify form actions. You can define where forms are allowed to submit to. You can say, I'm only going to allow forms to submit to these locations because I know, I trust what locations forms should be able to go to. There's a whole load more, workers-based URIs, plugins, sandboxes, all that sort of stuff. There's a full reference on those two links. I'll tweet them out after this. But there's loads of things. I can't cover them all here. I'm just going to cover, the basics behind it all. So those are the directives. I'm going to show you a few examples of what the kind of rules we can put in place are for these directives. Image source star. That's a wildcard. Basically says, allow any URL. I don't care where it comes from. Any URL is allowed. But don't allow things like data. Who's ever used like a base64 encoded data URI for an SVG? That wouldn't be allowed with this, because it's not a URL. But if you included it via a URL, it would go through fine. Same with blob and file system schemes, that kind of thing. Object source none would not allow anything, just blocks everything. Don't load anything. Anytime an object is tried to include, just get rid of it. Don't even load it, I don't want it. Self, style source. That would, and bear in mind, these can be used across directives as well. It's not just for these ones, these are just some examples. So this would allow you to load it from the same origin, as long as the host scheme and port match. So if it's a different port, different scheme, wouldn't match, so it doesn't allow it. But anything that's the same, that works with. Script source unsafe inline. It allows the use of inline elements, so on-click attributes, that kind of thing, as well as inline script tags, or say style tags if you're using it on that. Who's got inline scripts in their HTML on their websites? Yeah. Don't use unsafe inline. Losing the word, it's unsafe. Effectively, unsafe inline is like having all the protection in the world on your door and then leaving it unlocked. Doesn't stop anything. Unsafe inline basically says any script that can be input into the HTML source can run. Now, if you need to allow inline scripts, there's a way to do it by defining what ones can load. And you do that by what's called a nonce. And in the header, you send back nonce random. $random is a random string that you've generated. So each request, you generate a new random string, send it back in the header, and then when you run the script, you include it as a nonce attribute here. So that then means the browser goes, that script has got the nonce attribute, which must have come from the application that's generated this. I can load that script, I trust this, because this matches this. An attacker wouldn't generally, if they're storing XSS into your stuff, they're not going to be able to get this value. It has to be random on every request. If it's not random on every request, it's pointless. So if you're using something like Slim PHP, you can use middleware, which is what I'll be displaying in a minute. If you're using Symfony, you can use like a kernel response listener, that kind of thing. Most applications have a way to attach headers to a response, and you can do this kind of thing with it. So a content security policy, this is a short one. Looks something like this. It's long and complicated, and it gets longer and longer and longer. But there's a few things here. So I've got, don't allow anything by default. So if something isn't specified here, don't load it. Script source, self, and star.google.com. I've also got a nonce with a random string there. Style source, self, load things from myself, I don't care about anyone else. Image source, self, upgrade and secure requests. Form action, go to these ones, no one else. And there's another one there called report URI, which I'll cover later on in the talk. So, with all of this, I want you to learn from my mistakes. Here's the admission time. My name's Matt Brunt, and I broke production. It was a bad CSP that I uploaded, or I deployed on the site. I was all eager, security, let's do it, I'll make my site really secure. And I uploaded this content security policy, and in about half an hour we had phone calls from people saying, the site's not loading, this isn't working, what's going on? And then I go red-faced and realise what I've done. So don't do what I did, and I'm going to give you some implementation advice to avoid the things that I've done so that you don't get your bosses shouting at you. So, the implementation advice, report URI. I mentioned this previously. What this does is it allows you to send reports when a violation of your policy occurs. So if you've got a policy on your website and something violates that policy. So you've got a policy that says don't allow inline scripts, and somehow an inline script gets on your website and it's executed. The browser would block that if it's enforced. And with the report URI, it would send a JSON payload to that endpoint that says, hey, this page was loaded, this is the content security policy you've got, this was violated, here's the script that did it. And it sends you a JSON payload that says, gives you enough information to do that kind of thing. So when a policy failure occurs, it just sends a JSON payload to that URL and deals with it. JSON payload looks a little bit like this. So we have blocked URI, self, it happened on myself. Document URI, mysite.com. This came from a real payload that I was dealing with. I've anonymized the stuff and shortened it for sort of more conciseness on the slide. But you notice here that I've got my script policy says only allow scripts from myself, and then it's got a script sample. And it came from LastPass, which is a password manager. And what LastPass does with its password manager is to get the little images on input fields and do the things it does. It injects JavaScript into your DOM to do so. At which point my content security policy said, I'm not allowing you to do that. That's not going to happen. I had a lot of problems with this. I got on to the LastPass development team. I was speaking to them. They said it should work and there's some ways around it. I haven't checked back, but effectively they said there's not a lot we can do at this point. I think in the spec for CSP there's some talk of browsers allowing extensions in the browser to have like an elevated level of privileges that bypass content security policies. So with all of this, you've got a report URI, it sends a payload to an endpoint. You've got to have an endpoint to capture that payload and do something with it. You could write one yourself, but no one wants to do that because it's more work for payloads. So there's a website called reporturi.io. This is from a guy called Scott Helm. He's a great resource on content security policies and sort of this side of things. Really nice guy as well. And basically what that does is that's an endpoint that you can sign up. It gives you a URL that you can send your policy reports, your policy violations to. And it gives you graphs and charts and gives you breakdowns of what browser did it and all that sort of side of things. It's a really nice website and it really helps you with this, so use that. Now, the funny thing with Report URI is, Scott posted a blog post that was content security policies as an attack vector. Because what happened was, he's got reporturi.io, which is a website that handles payloads. Bear in mind, when a response is sent, a violation is sent, it's from the browser. It's not from the server, so it's the browser. And who's heard of Envato? It's a fairly popular site. It's one of the Alexa top 300 sites. Very popular site, lots of traffic. They use reporturi.io for their reporting, and they uploaded a misconfigured content security policy, at which point reporturi.io got DDoSed by everyone using Envato. At peak traffic, he had 4 load balancers, each with about 45,000 requests a second. That's traffic. So yeah, he had some fun with that one, trying to put out the fires as someone else broke his product. With all of this, there's a content security policy called report only. By default, a content security policy will enforce the rules that you tell it to. Report only allows you to implement a policy that doesn't actually get enforced. The browser doesn't enact the blocking, but it still sends the report to the report payload to the endpoint you specified. So what this allows you to do is it allows you to implement a policy that's testing. I've got a policy in place or I don't have one. I want to test what would happen. You implement report-only policies. And it allows you to get the reports, see what's happening, see things you need to fix, update your policy, try a new one. You can test the next version, and it's really, really handy. I didn't do this. I was stupid. Do this. It looks the same as a content security policy, except the header is content security policy - report only. That's it. Everything else works the same as a normal content security policy, but this doesn't enforce it, it just reports it. And you can have this in place, so you can trial stuff before you enforce it. You can have this in place with an actual content security policy that is blocking things. So you can report the next version, see what's happening on the next version you're going to implement, whilst the current version is in place. When you're comfortable that the next version is okay and is going to be ready for production use, move it across. So use report only. I want you to use it if you do implement a CSP, which you should do. I want you to love report only. And I want you to hate report only. Because report only has so much noise in it, it's crazy. With reporturi.io, we've got some fairly well-configured content security policies, but I'm still astounded every single day at how many report violations I get because some weird browser extension is trying to do something stupid. And the more popular your site is, the more reports you'll get, the more noise there is. So take all of this with a grain of salt. Content security policies are far from perfect. There will be noise, and lots of it. So, previously I've mentioned nonces. With nonces, don't generate multiples of them in the same request, but generate a new one each request. These are sort of the next tips that I've got for you for implementation. This is just to make your life easier. If you're using a templating engine, like Twig or any of the others that are out there, I pretty much only use Twig exclusively, add the nonce as a global variable to your template. A lot of templating engines have a way to access variables as like a global variable, so you don't have to assign it to every single template you use. That makes it easier to work with. Developers are more likely to do it. The more difficult things are every day, developers just aren't going to do it because we get frustrated. So make it as easy as possible. And write helpers to generate tags. If you want to output script tags, but you just get annoyed with adding the nonce every time, write a little helper function to do it for you. Just reduce that barrier to entry on all of this. Some general tips. Have an easy and quick way to disable content security policies in production. Because if you upload one that's bad, you're going to need to turn it off like that because things are going to go bad quickly. Better yet, have a way to switch it to report-only mode so you can continue to get logs for debugging. Because if you turn it off, those logs stop, it's no longer enforced. What went wrong? If you haven't got anything previously, it's going to be difficult to work out what was going wrong. Activate it in report-only mode, you'll still get the logs of things that were going wrong, but it won't be enacted. And add the CSP at application level. You could add it via, virtual host config, but you wouldn't be able to do nonsense like that necessarily. But do it at an application level because it's easier to turn on or off. If you need to turn it off and it's in your virtual host config, requires you to reload your web server with new configuration. Not the kind of thing I like doing all that often. So with all of this, it's up to your browser to support this, and it's up to your browser to help you enforce these things. So browser support, yeah, it's patchy. Chrome and Firefox have really good support for this. That's probably maybe a little bit too small for you to see. Chrome version 25 supports CSP level 1. There's also CSP level 2, which is the newer standard. That's supported by Chrome 40 Plus and was it Firefox 31 Plus. Microsoft have just announced that Edge will support CSP2 in 15.0 something, which is cool. Safari, yeah, it's got CSP level 1 support, but that's about it. There are some old sort of legacy headers, X-content security policy or X-WebKit CSP. They're deprecated, don't use those. And don't use those in combination with the actual ones that are supported because browsers do strange things sometimes with them. So that's kind of the talk side. I've got a little bit more later, but I'm going to go into a demo now and I'm going to actually break some stuff for you on a little demo site I've got and show you the kind of things that we can do with CSP. So, give me just a second. Mirror displays. Now I have no real pixels, but can everyone see that okay? Cool. Right, so this application is just a small, slim application that I've got, and it's running. Yeah, oh god, no space. So this is a website for the Ellingson Mineral Company. 10 points if you can guess where that's from. No one? Oh, it's from Hackers. The greatest movie of all time. It's not, but it's bad good. So the Ellingson Mineral Company, they've got a website and they've got a few pages on it. We've got a page on the Gibson, which is their amazing supercomputer. And the marketing team have told you, you know what, we need an alert to let the users know this page is totally secured, it's good. We're okay with this. So the Gibson computer, totally secured, that's cool. And they also have a place to store garbage files. And you can have your files secured, your super secret files are stored here. So I can put in here, this is a new file, and I can submit the note, and I get told, hey, this is a new file. What you might also notice, that if an attacker's on this website, we can start doing some fun things with this. Secure message, files updated. Okay. Oh, hello there, that's cool. That's nice. Huh, I wonder. Oh, fantastic. Excellent. I can do some really good things with their site now. So, the developer knows about this. They hear about this, and they think, oh God, we've got to stop this. In an ideal world, I'll show you the code behind this. This is in garbage files. This content is actually output as raw, which generally you won't do, because that's a bad idea. You'll be escaping everything, which Twig does by default. But for the purposes of this, I'm showing you what a bad example looks like. So that's output as raw. I could fix this by not doing raw, but for some reason they've decided we need raw because we need to allow some fancy stuff. Okay, fine. So I've now got this site with an XSS vulnerability via the browser, and I can put a hack in here. The fun thing is, given a browser being long enough, what happens if I did this? Oh, it's doing it. Chrome sometimes, with certain white space characters, doesn't show them. So if that went all the way across the edge, you wouldn't even know that that attack is in your browser because you wouldn't see it in the URL. Tom Scott posted a really interesting phishing attack recently that does this. Really quite funny. And scary, because if it wasn't for the fact that he had an ultra-wide monitor, he wouldn't have seen that at the end there was this extra bit of data. It was bizarre. So, this is an XSS vulnerability. We need to fix this. So we'll take this step and we'll implement a content security policy. So, if I go in here, I've got some middleware that's added to the site. And I've just got this new app middleware. You'll notice above it, I've got disable XSS protection middleware. Don't do that. By default, browsers have a lot of XSS protection built into them by default. If they detect a payload has got JavaScript and that type of thing in it, it will often block it. Browsers have got a lot of this protection in place by default. To demo this stuff, I need to turn off that protection. So as the note says, don't do this on your sites. Trust me, I'm not an expert, but yeah. So we've got our CSP middleware. And all this does is it takes from my container configuration a string which contains my content security policy and the generated nonce that I've got, which I'm using elsewhere in my application and is regenerated on every request. So what this does, effectively, it just adds a header to the response, so response with added header, content security policy, and then sprintf and move things in as you need to. So if I open security.php, this is my content security policy. So for now, I'm just going to remove that. And what we're going to do is we're going to say, right, I don't want to load anything. I'm going to get rid of everything. That will stop the hackers. I'll get rid of everything. So we save that, and then we load our site. Ooh, why isn't it working? Ah, that's right. And then nothing loads. I get no JavaScript, I get no CSS, I get no images, at which point I'm there going, oh, no, back to the computer, let's fix this. I didn't quite do it this bad in production, but yeah, 7 pages, nothing. So we go, okay, what I'm going to allow is, I'm going to allow a style source of self. That'll get my styles back. So if I reload this now, I get my CSS back. That's good. What I'm going to do is I'm going to allow a script source of self. And that runs, and I'm going to allow an image source of self.
You've got IMR, should it be IMG?
Oh, probably. There we go. Right, so now my images load, live demos, they're great. It's like peer programming, but with like 20 people. So I've now got my images back, and this loads, and that's cool, because I've now blocked that attack from the hacker. I've got rid of the XSS, that's awesome. And then I go back to my Gibson page, and oh no, my JavaScript isn't loading. That's a problem, because the marketing team's going to get on me and say, the users don't know that this page is super secure. What's wrong with you? So I'll go back and okay, I'll fix this. So I open up my Gibson page, and I notice that the script is actually in line. I could move this externally, but the script is in line, and for the purposes of this, it can't move. So I'm like, right, okay, what can I do? Ah, there's that amazing thing called the nonce in the content security policy. I can do that. And I'll add the nonce. And that's how I can add it. Because in my container, when I create Twig, I add the randomly generated nonce as a global variable to Twig. So any template that Twig renders has a variable called nonce available to it, which means that every time I render a view in my controller, I don't have to add this manually, it's just already there for me. Because if the developer has to add that on every view, there's going to be way more code than you need to do because it's not necessary, and people are going to either forget to do it or not do it because it's annoying. So now I can add that as a nonce, and I can go back to my security policy. If I undo back to what we had at the start, what you'll see here is, I'll get rid of that as well just for now. I've got this script source self and then just a sprintf placeholder there. That will get replaced with nonce dash and then the randomly generated string that I've got, which is also used as a Twig template variable. So when I go back to here and I reload the page, I get told super secure. The marketing team's happy. I'm no longer getting shouted at. Everyone's good. It's fantastic. We've got this protected. That's awesome. So now, this page is currently running over HTTPS, but I can show you how it works if it wasn't. So I've got this CSS file, and it loads over HTTP. Now this version of Chrome won't actually load it, it will just block it. It's not going to allow you to request insecure resources on a page that is by default asking for things on HTTPS. So, as previously mentioned in my policy, I can add that upgrade insecure request option. And now Chrome is going to go from being not loading the CSS to remain secure. I'm actually going to load the CSS and I can be secure. And in the source of the page, which is, oh god, there's no room. Tell you what. Let's just do view page source there. There we go. You'll see the resource is actually still being requested in the template as HTTPS. That hasn't been modified. But the browser knows, well, you've told me to upgrade any insecure requests that I'm sent and request that resource over HTTPS, which is really nice. So we've protected against a reflected XSS attack via this top bit here. But by also doing that, I've now stopped this happening. I save this, doesn't execute. If I didn't have my policy in place, this was blank. This is actually persisted on the back end, it's stored. That will be stored. So if the user is asked to implement that or have that inserted into their site, that would be executed on every request, but because of our content security policy, we've not only blocked a reflected XSS attack, which is via the URL, because that's not stored, it's reflected back to the user as a message that's submitted. We've also blocked a stored XSS attack, which comes from it being stored, in this case, in a cache file, could be via database, could be local storage. But because I'm executing JavaScript here, there's no reason I can't completely modify the DOM, move things out of the way, put something in local storage, steal session cookies, but you can stop that. Who's used HTTP only on cookies before? Who's only just hearing about HTTP only for the first time today? Go and put it on now. What it does is it basically enables that cookie as this flag on it, and then the browser will not allow you to access that cookie via JavaScript. So if malicious JavaScript did get onto your website, they can't steal your session cookie because it's told HTTP only. Again, relies on browser support, but this flag on cookies has been there since 2002 in Microsoft IE6, so there's no real excuse to not use it. So that's one really easy way to help protect against that stuff. That's an aside to this, but that's that. So, let's not get rid of this page anymore. So, I've mentioned it previously. Go and follow this guy, Scott Helm. He really knows his stuff with this. That's not me, obviously. But he really knows his stuff with this. He runs reporturi.io, which is a service that I and thousands of other people use. I've spoken with him at length on this stuff, and he really knows it. He's really friendly, really approachable. Gave me a lot of his time to talk through this. Here's some links and further reading. There's a whole list of those. That's your homework. Don't hate me for it. But really, there's a lot of really good stuff there. The OWASP guide is one of the first places to start for this. XSS is part of the OWASP top 10, so go read that. ContentSecurityPolicy.com contains directives to help you do this. ReportURI.io is a website to help you deal with reporting. It's also got a content security policy generator. So if you want help generating the content security policy, you can just tick boxes and enter in a few domain names. And it will go, here's the string to put in your header. There you go, that'll do the job. It's really handy for that sort of thing. Just to, again, reduce that barrier to entry and make it easier for you to do this stuff. Edge scan report, that's the one I mentioned earlier with the 52% of vulnerabilities found were XSS based. So that's over half. This isn't, silly little stuff. It's pretty serious. With all of this, leave me some feedback if you want to. If you don't, it doesn't matter. It would be nice. I'm giving this talk in a few places, so it would be good to know where I can improve, things that you wanted to be covered, things that weren't, that sort of thing. Thank you very much for all of this, for coming along and hearing me talk. And has anyone got any questions? Yes?
Yeah, this is to do with, you mentioned something to do with some directive which would turn browser anti-XSS things off. How does that work? The reason I'm interested, by the way, is I teach PHP, and there is an XSS week that I do. And if browser-based protections can be turned off, then maybe it would improve the way in which XSS could be illustrated.
That's why I turned it off as a demo, because if I hadn't turned it off, a lot of that stuff just wouldn't work anyway, because the browser's kind of got their default protection. I'll show you that actually, it's a lot easier. It's not actually a CSP directive, it's a separate header.
Yes.
There's like a group of security headers that help with this sort of thing. So if I go back to mirroring, and I go back to here, and I look at my middleware, all this does is it sends back a header that is XSS protection and sets the value to 0.
Oh, right.
So as long as you set that header back, the browser goes, I'm not going to bother helping you here, you're on your own. And that's how that works, yeah. By default, it's set to 1, or you can set it to 1 yourself. Any question? Yes.
You mentioned that the browsers were thinking of adding an elevated permission level for extensions.
Yes.
That bypasses the XSS. How are they then going to prevent browser extensions exploiting the browser?
It's why that kind of thing doesn't explicitly exist at the minute, because it's that exact question. They've kind of got to have a somewhat elevated permission level because the users installed them and sort of inherently trusts them, but there's so many extensions on the Chrome store, you can't always keep up with what's there. I don't know that off the top of my head, and I don't really want to be the person who kind of has to think that one through, because that's going to be a difficult one. I did read through the spec that there's certain things that a browser extension can do, such as injecting scripts. But again, it's one of those, if it can do that, then it can do anything. So,
Yeah.
but then again, when you install an extension, you get told, hey, it's got access to your history. What's to stop it sending your history off to someone else, for example? I guess it's a level of trust. You can't protect against everything. I'm personally, if I'm honest, not a fan of extensions having this kind of elevated permission level, unless it's really tightly restricted to only allow them to do very, very specific things. So they can't include external resources, and they've got like a very limited subset of the JavaScript API that they can work with, for example. That would probably be a good compromise, but I couldn't say off the top of my head. Any other questions? Yes.
I'm not confused with integrity checks for XSS, but it's like a good idea to use them on scripts.
Integrity check, yes. There's also sort of, it's not strictly CSP, but if you're including external resources, you can tell it the SHA of the file. And what that will do is it will basically say, when you include that file, this is the SHA it must match. Because obviously if you're including it from Google's site, and you're trusting them, then you're saying, I trust whatever they send me. But if they get compromised, well, you're now compromised. So you can specify the SHA as a sub-resource integrity check on the file, on the script when you include it. And that basically says, if the hash of this file doesn't match this, don't load it, and the browsers do that as well. So I would use that in combination with this stuff as well, yeah. Yes?
I came across this topic, last week, as well, working with Backgap.
Okay.
And I don't know if you're familiar with it.
Yeah, I've used it previously, yeah.
Yeah, so and the CSPs in there are put into DOM in a meta tag. So is that?
You can do it via a meta tag.
Is it
There's certain things you can't do with the meta tag. I don't think you can enforce report only via the meta tag. You can put it in via a meta tag. I don't like the idea of that. I don't know why, it just doesn't sit right with me, but it can be done. There is a meta tag available for it. I've just always used the header because that feels a bit easier to me. I find it easier to attach a header to a response than having to modify my markup to allow that. But it works with the meta tag, it's valid, it's part of the spec, it can be done. I don't know if it can do all of the things that a CSP can do. I think it can, but I don't think it can do report-only mode, which is, to me, if it can't do that, I'm not going to implement it. I'm just going to do it via the header. But it is a valid way of doing it, yes.
I assume that on Backgap because it's the DOM is going to be stored on the device, and yeah, so it hasn't got.
Yeah. I would say, if anything, yeah, it's got, because it is just HTML browser, yeah, you've got no other way of really updating it, because it's not technically sending back headers. I mean, it must maybe runs an internal server to serve the page. I don't know the internals of that, but I'd imagine it's probably an limitation with how they're serving the pages within the embedded browser. So that's probably why they've gone down that route. Any other questions? Yes.
There's two questions actually.
Yeah.
First one was, are there any ways of preventing HTML injection? Because it only prevents scripts, so isn't it? You can still put HTML on the page.
Yeah.
Like a parameter.
There's not a lot you could do to protect against that because there's no differentiating that HTML between valid HTML.
Yeah.
That would be where things like escaping and whatnot comes into play.
Yeah, you have to use escaping to really.
Yeah, because your CSP couldn't tell you what.
Does it?
Yeah, it couldn't tell you what the HTML structure that's allowed to load is. That
Yeah.
you have to send the whole document back in the header to say this is what it
it's
should
not
be.
going to like inject a form into a page potentially.
Yeah, but if it was a form, you could protect against that with the form.
Oh, that's true.
The form URI don't allow any external forms, for example. That'd be a way to protect against that one.
That's true.
The sort of the malicious things you could do with HTML, forms, images, what are we thinking here? Objects, iframes, that kind of thing. You can control those with CSP.
Dodgy links.
Dodgy links. That's a good one. Yeah, I mean, you couldn't stop them putting in a dodgy link. This is an example where that CSP can't protect you from that. It can't stop someone putting a link in. But that's where you'd have to be doing proper escaping on that side of things. By default, you should be doing escaping anyway. This just kind of is another layer. If for whatever reason escaping you forget to or something happens, this is kind of another layer on top of that to protect against it. But yeah, CSP wouldn't necessarily protect you against a bad link.
And do you know any bypasses for these headers? You can do?
When you say bypasses?
Well, I read about there's ways of bypassing it, like non-subjection. I haven't read into it. But,
Well, yeah, I mean, obviously, if if for whatever reason they could read the header in the script that they had uploaded onto your site, then they could obviously read the nonce and output a script tag with that nonce on there. That would be a vulnerability. But that wouldn't necessarily be a HTML-based thing. That would probably be somewhere else in your app. They've got access to the code, the PHP code, for example. This is where the console can't protect you necessarily, because via the console, because it's got an elevated level of sort of permissions. If I tell someone, hey, go and run this code on the console, I can effectively just inject a script onto the page, and the thing's already loaded. The browser's not going to stop me. Or if I need the nonce, well then fine, run a little script at the start that scans through all script tags on the page, pull out the nonce, and then attach that to the script that you're inserting. But that's the console having an elevated level of permission. And if someone's executing code that someone else is telling them to, I can put messages to tell them to stop doing it, but I can't stop them doing that because the console is a developer tool. It's meant to have that level of, it's bypassing all that because you're trusted to know what you're doing.
Yeah.
If you do find those links, send them to me. I'd love to take a look at them.
I have one here, I just haven't read it yet.
Okay. Any other questions? Cool. Thank you very much for listening. Go and implement CSPs. Don't break production, but if you do, don't shout at me. Cheers. Thanks, guys.